exception. So, 2 words here and there, or 2 towns jumping around the categories. So, yeah.
They still have that great money professors stuff up. Yeah.
Good evening, everyone.
See you later.
There may be some people coming in a little while, but I think we ought to start. My name is Beth Stevens, and I head up the Civics for the Community series, which is sponsored by Highland Park. And want to welcome you all. Do want to, before we go into tonight's session, just want to give a little forward advertising. On November 18th, we're going to be having another session, and that's going to be on age-friendly communities. Basically all about how Highland Park can develop institutions and arrangements that would help people stay in their homes later in life. So that's going to be on November 18th. All right. Our speaker tonight is David Robinson, who's a distinguished professor in the geography department at Rutgers, as well as our official state climatologist here in New Jersey. His research, as he put it in his bio, ranges from global to local, which basically means that he's really interested in trying to develop better understandings of how climates, better of the climate system, I should say. As New Jersey's state climatologist, he does applied research, and it focuses on the diverse weather climates here in New Jersey. And this includes climate change. And his work and his thinking looks into how climate change is having an influence on transportation, agriculture, public safety, and commerce. Tonight, he'll be talking to us about climate change in New Jersey and what we'll be facing in the coming decades. Professor David Robinson.
Thank you, Beth. Pleasure to be here, just around the corner. I was telling Beth, I'm the only one in my department who doesn't live in Highland Park. So one of your neighbors has got to be a geography professor or a grad student here at the university, because we're over on the Livingston campus. So I see bikes coming in the mornings with faculty members on them, and I tell them to get home before dark. And they always ask me, when's it going to start raining, so they know when to leave. So very familiar with the community, and just introduced Pad Thai restaurant to my colleague from the University of Georgia who was visiting today. Actually, it's his second time up here at the restaurant, but we were just over there having a good dinner. But I didn't get the spiciness because I knew I was coming to talk tonight, so I said, keep it mild. But anyway, it is a pleasure to be here today. Yeah, there's a lot going on. There's always something to talk about when it comes to the climate. Whether it's weather or climate, it may confuse you. I am a climatologist. I'm not a meteorologist. That keeps me out of trouble from predicting weather day to day. But you have to know enough about the weather to be a good climatologist, vice versa. So sometimes it's that not a very solid line separating the two. We might talk about the warmth we had. Remember earlier in this month, 95 degrees in New Brunswick? Okay, that's a weather event on that day, but I go into the history books and found that we have a weather station at the Rutgers Gardens and another one in downtown New Brunswick since 1893. And that was the warmest October day on record. So that's when the climatology comes in. It's not a gee whiz, it's like, wow, kind of type of experience. Yet 2 days later, we have a weather network of 65 stations around the state, and our station up in Walpack in a valley in Sussex County got down to 27 degrees. And they cracked the freezing mark just before midnight on the 4th, and of course the heat was on the 2nd. Then go back a week ago, what happened last Wednesday night, we had a bomb cyclone, essentially, a cyclone, a low pressure system that deepens incredibly rapidly in a 24-hour period. It exceeded the definition of meeting bomb criteria by 1.5 times in terms of the pressure fall. And our network had 5 stations gusting between 50 and 64 miles an hour. Up on Cape Cod, they had a 90-mile-an-hour gust, and we had 2 or 3 inches of rain. Oh yeah, that reminds me. We were in the middle of a flash drought earlier this month and back in September. We're still in that categorization as we wait to see if we can resume normal precipitation values for a month or two. But that's not so important for water resources because we just finished the wettest 12-month period on record, and 2018 was the wettest 12-month period since 1895 in New Jersey, so the reservoirs are doing okay. They're down, as they always are in the fall, but not down even to normal levels. So here we're having this flash drought, and our water resources are fine, but our lawns aren't, and some late season agriculture is not so great. But my friend who owns a vineyard out in Warren County thought it was great because it was just the right conditions of warmth and dryness for harvesting. So all of these things are weather and climate. And that's why you might get a little confused sometimes when I'm going back and forth and, on the two. But primarily we're going to be gearing towards climate tonight. This is a little bit, I don't know where to stand to be out of your way and be on the camera. Oh, I'll keep moving to keep the camera going. A little bit about the State Climate Office, our climate system, a little retrospective on weather and climate in the state. Then look at climate change, past, present, and future. And then just a very short part on impacts and potential actions. I know a couple of my colleagues on the social science side who you just might get to come walk up the street and give a talk on that. But we'll broach that a little bit as well. State Climate Office. Anybody ever knew we had a State Climate Office? It's all right. It's been at Rutgers since the late 1970s after it was a federal position earlier. I'm the 3rd state climatologist who's been appointed by the dean of what was Cook College and the Ag Experiment Station, now SEBS and Ag Experiment Station. I was appointed back in September of 1991. It makes me old. Makes me the longest serving state climatologist in the country by 5 years right now. I was very young. Yeah. But it was just something that was a service activity. We are the state university. Governor Byrne, back in the late 70s, decreed that it should be the home of the state climatologist. There's a state geologist. Jeff Hoffman is at the DEP, so he's a state employee. And we will soon hopefully have a state oceanographer. It looks like it just hasn't been signed off on yet. It's Josh Kohut, it will be Josh Kohut, who's a colleague of mine over marine science, and he's a great guy. We're working together on a variety of coastal issues, from wind farms to coastal agricultural lands and all. So we've had a great working relationship. So we help people make decisions is what it comes down to. With our weather network, it could be what to wear when you go out the door in the morning, or it could be advising the governor when Sandy's coming along and our stations are measuring wind gusts of 80 and 90 miles an hour, and we're looking at tide gauges along the coast, not ours, but reporting on that. And the fact is we can bring it locally. The National Weather Service is great for forecasting. We have 2 offices that serve New Jersey. The one in Mount Holly serves the most of Jersey, but also eastern Pennsylvania, all of Delaware, and Cecil County, Maryland. So they can't put all their attention to New Jersey. And the one out of Upton, out on near Brookhaven on eastern Long Island, does the northeast part of New Jersey, and Rockland and Orange County, all of the 5 boroughs, all of Long Island, and the south coast of Connecticut. So we, as the State Climate Office, can pay attention to our state, only our state, and we know the terrain. I know it pretty well because I grew up in New Jersey. I'm one of those rare Rutgers professors who's a native of New Jersey. So there we are, locals trusting locals. We keep our finger on the pulse of what's going on. This isn't all about climate change. It's very much applied climate is what we do. Sure, there's a lot of interest in climate change, but a lot of it's just baseline climate, applied climate. Here, for instance, these graphs are on our website, and they get a lot of attention. The top left graph is looked at by DEP and the drought program there, and I sit on their drought committee. It's 12 months of rainfall anomalies. Anything in green has been an above average precipitation month over the last 12 months, from October of last year through September. Anything red is below average precipitation, and you can see here in September, 3 inches almost below average. That's our driest month since September, it happened to be September, of 2007. We haven't had a month that dry. We've been on a good roll for moisture, for sure. And you can see how we built up such a surplus with the wet months we had earlier. And this is the same thing for temperature anomalies. Anything in red is warmer than average for that particular month in the last 12. And blue is below average. And yeah, we had last November was cold, and the rest of the winter was on the mild side. We had until we got to March. But we've had 2 months in the last 12 with below average temperatures. And in the midst of that, the 4th warmest April in 125 years of record, the 5th warmest July, the 8th warmest September. You just lived through the 8th warmest September. Didn't seem too impressive, huh? That's because it was only the 5th warmest of the decade. We were just cooking in September. And the summer itself was the 5th warmest, and I think 4 of the top 5 warmest summers have all been this decade as well for the whole summer. So anyway, these tell a story, and that's what we're here to do, is convey story, convey information. We have a weather network I mentioned. Again, stations from West Cape May to High Point Monument and all points in between. Closest to here is at Rutgers Gardens. It's in collaboration with the Weather Service station that's been there for over a century. We've only had electronic equipment reporting every 5 minutes for the last 15 years or so. But we tie it all in and provide, essentially keeping our finger on the pulse of things. And then we have a volunteer network of observers who observe precipitation. I don't know if there are any Kokoras observers in here. It's the Community Collaborative Rain, Hail, and Snow Network. I know there's been some from Highland Park, Piscataway, New Brunswick. We have about 250 to 300 observers. Citizen science at its best. And they go out daily with a standard rain gauge, and they report rainfall. They go online and enter the data. They measure snow in the winter. And we put a map together electronically every day. These are not from our electronic network. These are from our actual volunteers. And you can see how precipitation can vary so much around the state, why we need all these observers. Very little here and here, a lot here, 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 and here, and a little bit in between. So it really, again, helps us keep our finger on the pulse of what's going on around the state. Precip, temperature, environmentally speaking. So anyway, that's it for the State Climate Office. I do have some brochures if anyone's interested in learning more about the COCORAS program later on. You don't take an oath to do it every day. People miss days, people go away. We have about 100 of our 250 to 300 observers hardly ever miss a day. It's amazing. We send them certificates, and we get notes back from them saying, I just went to buy a frame for it. It just makes my day. But you can't miss more than a week's worth of obs or no certificate. But we take multi-day obs. If you're away for a couple days, you can give a multi-day report. Anyway, climate system. Let's talk about the climate system very briefly. Climate 101 in one slide, essentially. It's very complex. It involves the sun, the furnace, if you will, and the atmosphere, the oceans, all the hydrosphere, the rivers, the lakes, the groundwater, the precipitation. It involves the land, be it volcanic activity or the positioning of our continents, which over the very, very long millions of years can dictate the general climate of the Earth. Then it involves the cryosphere, the snow, the sea ice, alpine glaciers, Greenland, Antarctic ice sheets. My specialty, my research is in snow cover. I study global snow cover and keep the go-to database on the distribution of snow on northern hemisphere lands, simply because someone has to do it, right? I've been doing it since grad school days and made wonderful national, international colleagues. My colleague from the University of Georgia was up. He studies the surface condition of the Greenland ice sheet when it gets wet from being exceptionally warm over Greenland. And also joining us at dinner was Professor Rettelbaum from my department, and she studies the plumbing of the Greenland ice sheet and the discharge of water from the Greenland ice sheet. So we had a cryospheric dinner over there at a tropical restaurant, I guess you could say. But the cryosphere, big role in the climate system. I forgot the biosphere as well, be it everything from deserts, I suppose, to rainforest and anything in between. Oh yeah, there's something else I forgot. Look who's dead center in there. It's human activities, be it farming, be it industrial activity, and whatnot. And that plays certainly a role in our climate system. Very complex. You cannot isolate any one of these. Notice I keep saying system, system, system. System doesn't really have a beginning or an end, and you can't dislodge one part of it and talk solely about that system alone. It interacts with all the other systems, which makes it fascinating. And I teach a course of 350 students in it this spring called Earth Systems. And some of it's climate related, some of it's just looking at surface landforms and such, but you just can't pick it apart and only look at it individually. It is an integrated system, which just makes it so interesting. There's your street fair. Jersey weather and climate, a little bit on that. We're a small state, but we get quite a variety of weather. I recapped what we've had this month. You know, Outlook actually has some snow flurries in the forecast for Halloween. At least my son texted me that today. I haven't had a chance to look at it. But that's state writ large, if you will. But we can kind of break the state into multiple climate zones. And you know, look where we are. We're pretty close to 1, 2, 3, 4 of them here in central New Jersey, and not too far from the fifth. But they're a function of topography, elevation, or the lack thereof. Latitude, it's a couple degrees of latitude, but it's a pretty big difference between Cape May, which is the latitude of Washington and Baltimore, essentially, and the high point where you're talking southern New England, Connecticut coast, and northern Pennsylvania. So that can make something of a difference. By surface conditions, talking about the sandy pinelands, which have very much have extremes in temperatures, hotter days, colder nights with the sandy soils, to the urban environments, really up through here, the interim called Central or Piedmont zone, where we've got a lot of urban lands that hold a lot of heat at night, or produce a lot of heat at night, be it from air conditioning or from heating, and even have some impact with warmer days as well. So we have varied surface conditions. And then finally, the land-water contrast, which is quite a big deal if you've ever been on the beach and waited for that sea breeze to come in to cool things off on a hot summer's day. These are areas that may not see their first freeze until after Thanksgiving, while we had the first freeze here in October. The growing season tends to range, have a difference of over 100 days in the state. In other words, these areas down along the southern coast stay above freezing from spring till fall for 105 days longer than some of the valleys up in the northwest part of the state, which may freeze on Memorial Day and freeze again by the fall equinox. So it's quite a range in our mighty but small state. But we get a lot of variety, and that's what I love. I was born and raised on the variety of the weather and climate of the state. But the good part is, despite getting all the taste for all these things, and I know some people are just fed up with some of these sometimes, we tend not to get the worst of the worst. I know we had Sandy. You want me to paint you a much worse scenario than Sandy? We could quite easily. We didn't even have hurricane force wind, except for some gusts along the coast, but sustained winds. We didn't come close to hurricane force winds. And we had very little rain in the Raritan Basin. The rain was 10, 12 inches down in Cape May, but they had less wind. So anyway, we could talk about that later maybe, but we get a variety, but we tend not to get the worst tornadoes. That hail is actually from Livingston campus about 10 years ago on a July afternoon. Of course, we get some major snowstorms. We'll see a Highland Park snow photo in a while. Ice storms, they're the worst. Freezing rain that freezes on contact. The ground's cold enough to freeze it, but the air isn't cold enough to freeze that raindrop into an ice pellet. So it just grabs on everything. We have drought, but again, it's been 2002 since we had a drought emergency. That's up the Raritan at Spruce Run Reservoir. That's in March. It was less than 50% full in March 2002. Normally it's full in March, only to empty during the fall. So no wonder we had a drought emergency at that time. This is a flash flood up in Little Falls last summer. It took a car dealership and washed it downstream. Of course, fire in the Pinelands is a big, big concern and a major threat, particularly in the Pinelands. We work with the U.S. Forest Service and New Jersey Forest Service, which is part of DEP. We have a special website where we, every 5 minutes, update fire danger conditions in the Pinelands, and they can go in and see, oh, it's windy, oh, the humidity's really low, oh, we haven't had any rain, and use that to assess fire danger, and during active fires, use it as background information. Oh, and it also helps them decide if they're going to do prescribed burns. And it's not a good day to do a prescribed burn, and they'll look at this page. So we're very much involved with that. And then, of course, that's Maniloking split in two with Sandy. But we don't have to go that far. Sometimes we get a lot of precipitation in the state generally, 4 inches a month on average, every month of the year, which is great. But sometimes we get too much. You recognize that? That's Route 18. That's Irene 18. I have some Floyd 18 images where you can see Commercial Avenue light before they redid 18. But sometimes we have too much, and we'll talk a little bit about that more later. But again, sometimes too little. This is a drought in '81 at the Wanacue Reservoir. This led to an act where they built the Monksville Reservoir upstream between Greenwood Lake and Wanacue Reservoir. The last reservoir built in New Jersey. There has not been one since.
Where's that?
That is in Passaic County, up off 287 as you go up to the north there. So that was the one. It's one of the bigger reservoirs in the state. It's not as big as, I think it's the second biggest after Round Valley, which dwarfs the others. So that's Wanacue. Bad shape. Now there's a pipeline connecting Wanacue and Oradell Reservoir. There's a pumping station on the Passaic River that can pump into Wanacue. A couple of years ago we were dry. It essentially pumped as much water out of the Passaic, which would have gone into the ocean, to fill Wanacue. But legally you can't pump out of the Passaic in the summer because you want to keep passing flows to keep the fish alive and happy. Except a couple of years ago we had so much rain in August they allowed them to pump in August. So we're in a tight bind when it comes to water resources in the state, especially when someone turns off the faucet and it stops raining. Again, there's Floyd. There he is. I thought I threw it in. That's Commercial Avenue. Anybody remember the Gulf Station corner Commercial? And yet another light that was on 18. And of course, that's the Hyatt and J&J. And upstream Bound Brook, massive flooding. They have flood control there now. That should not happen again unless you have something that would greatly exceed Floyd and Irene, which I just shudder to think that might happen. And then we get snow. I can't remember what street. Tell me what street in Highland Park that is. One of our grad students took that shot back in 2010 and a couple other snow shots. I think it's second, maybe third on the other side. I think they had a couple grad students shared a house there. But this was a storm that split the state up the middle. The western side kind of slid off the slide here. The Delaware Valley, 4 or 5 inches of snow fell. Up the Garden State Parkway, 2 to 2.5 feet of snow fell. And it was just a matter of the precip just making it into Jersey and never making it over to the Delaware too much. It wasn't that it was too warm there. It was plenty cold enough to snow. Just didn't get the moisture there. I was living in Hillsborough at the time. I had 17 inches on the east side of town. The west side of town had 6 inches. So I was out in Flemington the next day, and it was blown off most of the fields, and I came back and went cross-country skiing. So I was a happy camper. And there's Irene, the equivalent of Floyd in many respects, and this is the flooding that's so persistent in Manville. Then Sandy, a truly transformative event for the state, emotionally, culturally, economically, environmentally, with the flooding of Hoboken, hundreds of thousands of trees down, a storm surge at Holgate, south end of LBI, and in Raritan Bay. Storm surges at Sandy Hook. The gauge was blown out there, but we did reconnaissance afterwards and figured the water level is 4 feet higher than any other time in the last century. It beat out, I can't remember the one storm, the other storm was Hurricane Donna in 1960, 4 feet above anything recorded previously. So it was just a monster of an event. So on we go to climate change. Climate has always changed. That's something you hear from a lot of people out there. Oh, the climate's always changing. What's so special about today? Well, I think it's important to address it head on. The climate has always changed. That area in light blue was under upwards of 1,000 to 2,000 feet of ice 20,000 years ago. That's peanuts, geologically speaking. The dark blue, sometime in the last 500,000 years or so, had an ice sheet moved down from the north and covered. There's so much water was tied up with snowfall and ice on land that sea level was hundreds of feet lower, and you had to go out to the continental shelf slope boundary to go to the beach. Because it's a little chillier. It's not like we didn't have some summer. It's not like the snow didn't melt off the ice here in our summers, but it was a very, very different world. But these changes took place over 20, 40, 100,000 year cycles. Tens of thousands of years, keep that in mind. It took to build ice sheet, it took 10,000 years for them to melt back. They melt back a lot quicker than they grow. But it's part of climate change. And humans have nothing to do with this. This has to do with the way the Earth rotates around the sun, and it leans on its axis. We're pretty sure we understand a lot of this. This is back grad school days. I was studying with some of the people who were proving this paradigm. Some of you really read about it, the Milankovitch parameters and such, linked with climate change. But let's just jump right to the crux of the issue here that I think brought many of you out tonight. What about climate now? What's going on with our climate today? And things are happening. And this is a synopsis of what I feel about it, obviously what many of my colleagues feel about it, and in general, a report from the National Climate Assessment and the Intergovernmental Panel on Climate Change, the IPCC, which about, was it 6 or 7 of us at Rutgers have involved the IPCC. It's the group that shared the Nobel Prize in 2007 with Al Gore with his Inconvenient Truth. So I'm just one of the IPCCers, if you will, at Rutgers. But you put a lot of scientists together. We presented a report. Then it goes to political entities who vet that report. If anything, it's a somewhat conservative document because there has to be a consensus generated, not just among scientists, which is next to impossible, but between governments, which it's hard to believe it is possible. But when you put it all together, we're talking about theory, we're talking about observations and models that tell us the climate is changing, and yes, humans are responsible for a significant part of that change. And we'll put a time period on there. It's, jump right to it. It's about the last 50 years where there's been a demonstrable evidence of human activities changing the climate, emerging from a very noisy natural climate system, which has El Niños and La Niñas and North Atlantic oscillations and Pacific decadal oscillations. Notice none of these Milankovitch, they take place over thousands of years. We're talking about things over years and decades. Oh yeah, volcanic eruptions too, and things like that, which can change the climate naturally. But we've seen the human signal emerge from that noise. And we look at the greenhouse theory again, we look at observations galore, and then we have these sophisticated computer models that can reproduce the past century's climate, but only reproduce it by putting human activities in. And that's our eyes to the future in what may hold with the climate. And we'll talk about that some too. This greenhouse effect, it looks confusing. Yeah, some of my students might say it's a bit confusing. But essentially, it's a balance. It's an attempt of radiative balance. In order to maintain somewhat of a constant temperature on Earth, you have to have as much energy coming in, leaving the Earth system, than is coming in from the sun. It's in general that simple. Of course, a lot of happens to the incoming radiation, and then the outgoing radiation, that's where it gets tricky and the greenhouse effect comes in. Because it's easier to get the solar energy in than it is to get the Earth's warmth heated up by the sun to get it out. And I like to use the analogy of a blanket. We have a natural blanket over the Earth of these what are called greenhouse gases. Carbon dioxide, methane. You may hear, oh, that's what humans are putting in the atmosphere. Yeah, but there's a natural carbon dioxide, natural methane, and the most prevalent greenhouse gas is water vapor. Humans don't play a big role in adding or pulling water vapor directly out of the atmosphere. We indirectly change it. We do directly change carbon dioxide and methane levels, and we put some human-made chemicals in the atmosphere like chlorofluorocarbons. But I'm getting ahead of myself. We have a natural blanket on the Earth. If we did not have a natural greenhouse effect, the sun only produces enough energy to bring the Earth to a balmy 0 degrees Fahrenheit. So how do we get it to a habitable planet where water exists as liquid, ice, and water vapor? Well, we have this blanket. In this case, it's your body producing the heat. But let's pretend that it was sunlight that came through the blanket and warmed you up. You put a blanket on you, and it slows the departure of that heat from your body. Now, eventually, it's going to get out of the top of the blanket and into your bedroom, as I like to say, otherwise you're going to burst into flames sometimes during the night. But it slows that loss. So what happens if you're still cold? Don't say turn the electric blanket on. Put another blanket on. And it will slow the departure of that energy, that heat from your body, longer. But again, eventually it will leave the top of the blanket and reach some kind of balance. So what we're doing is taking a natural greenhouse effect that keeps the planet generally interglacial at about 59 degrees Fahrenheit, all the way up from 0. And it's just putting another thin blanket on the bed, enough that we've already raised temperatures a couple degrees Fahrenheit in the last century or so here in New Jersey. And we're destined to raise them more into the future, but not 50 degrees more in the future, but more enough in the future to disrupt weather patterns, precipitation patterns, change sea level, and so on and so forth, really disrupt things greatly. So that's essentially the greenhouse. It's a natural blanket, and all we're doing is throwing another blanket on the bed as we humans, and as such, changing our climate system. And one of the culprits is carbon dioxide. These levels are post-industrial, measured since the late 50s. Pre-industrial values, interglacial, about 280 parts per million. Glacial values, about 200 parts per million, excuse me. So that's how it's vacillated. We're at 410 and counting now. It's been several million years since there was this much carbon dioxide in the atmosphere. Now you hear people say, but it's a trace gas. I just said parts per million. You might talk about methane is even less abundant. So they're trace gases. But there are feedbacks in the atmosphere. If you put these trace gases in, they grab some of that outgoing radiation, they're part of that blanket, and they warm the atmosphere. And a warmer atmosphere has the potential of holding more water vapor. That's how you get more water vapor. It's the potential, you have to get it there. But for every 7% increase in water vapor in the atmosphere is equated with about a degree C, 1.8 degree Fahrenheit, about a degree C rise in temperature. So a warmer atmosphere has the potential of holding more water vapor. So it's a feedback. You increase the trace gases, they increase the water vapor, and the water vapor and the trace gases act in combination as that added blanket, as that greenhouse effect. So trace gases can have a disproportional impact because of the feedbacks associated with water vapor, for instance. So it is a big deal. And these numbers are just going up and up and up. And I know everybody in the room is thinking, all right, how old am I and where was I when I was in high school and grad school? Or, you know, you think where it must be or might be heading. And there is some connection. This is only the latter part, but this is global temperatures going back to 1880. And anything in blue is below the long-term average. Anything in red is above the long-term average. These are the observations we were talking about. Not the month-to-month observations I showed you at the beginning. That's important for applied climate type of issues. This is looking back at change. So essentially, since 1980, we haven't had a year where the globe has been below the long-term average. And as a matter of fact, the last 5 years, 1, 2, 3, 4, 5, have been the 5 warmest on record. And guess what? With 2 months, 3 months, the end of September values, there's a 99% chance already this year is going to be either the 2nd, 3rd, or 4th warmest on record. Probably not going to be 2016 for the warmest, but we may end up beating 2015 for number 2. It's been that warm. The globe just had its warmest September on record. Again, back to 1880. So it continues, and we warm, and we warm, and we warm. I tell my students, you come onto campus in September now, and you're wearing shorts all month. We used to wear jackets. I have a colleague at the University of Delaware tell me a couple weeks ago when I was down there, he goes, I've been here 30 years. I ride my bike in every day. I used to wear long pants, riding it in come the beginning of the semester. He goes, now I have to bring a change of clothes because I just can't teach with shorts on. But that's where you start noticing these things. When you've done something repetitively for a long period of time, and you realize you're doing a little bit differently now. At a given time, or doing it at a different time of the year, perhaps. So these are the subtle things that are being noticed. But we have observations to really pin it down. This is Jersey. This is where we are in Jersey. Now notice, the last 5 years haven't been the warmest. 2012 was the warmest, but that's because we're local. And we're affected by jet stream patterns, ocean temperatures. There's always going to be the local variability, but we're in the same direction. And if you look just past the late 70s onward, we're even at a steeper slope than before. But I don't like to just start the slope here because I don't want to exaggerate. I want to give you the straight story. But you can see this slope is more subtle than this slope would be. So we picked up the pace of warming. And again, 6 of the 7 warmest years since 2006. And that's going back to 1895. Uh-oh, did I lose it? Oh yeah, I have to talk to you again. Let me come over here and give a little different perspective here. All right, we talked sand. There. There we were. See, you didn't like this slide. I put this slide on purpose. I don't mean to make light of this, obviously, but it tells a story. And that's what I've learned from my social sciences colleagues. I've learned from the people up on the Hill in Washington when they had me down to talk about my snow work and talk about some of this. They want stories. They don't want a lot of graphs and maps and all. I mean, you folks are coming here tonight to get the full picture, but oftentimes it's just telling a story. Today Show did something on climate change based off a Washington Post article I did a lot of work with their reporters on. And they went up to Hoboken, where there's a big algae problem. And they talked to a variety of people there, ice fishermen who aren't fishing that often, people getting hurt economically at marinas, a woman who couldn't bring her kids out to swim and she grew up swimming there. They ran tape on me for a half an hour for this Today Show. I was telling Beth before, I was in the piece for one sentence. I'm used to it. I'm used to it. One sentence, and that was saying that humans are having a major impact on the climate system today, basically. I was the science cred, if you will. And then they went for the human interest. You know what? That's all right. I kind of get it. That's sometimes what you have to do. And I've gone to many a meeting where I talk climate on the dais, and then they go into impacts, folks. And when the question and answer time comes, I don't get any questions. It's okay, because you need to have that scientific understanding, but then people want to know more what to do about it, what it's impacting, what to do about it. So I get it. So tell a story. And hopefully I'm doing that with a little bit of, obviously, a science leaning tonight. And now on to precipitation. This is the last 125 years of precipitation in New Jersey. Annual precipitation, and you can see a generally about 5% increase in precipitation. And with that, the drought years of the 60s, I dare say some people in here may remember, I do, and our 2 wettest years on record, 2011 and 2018. A number of very wet years the last several decades. We've had some dry ones. But notice the range is wider than it was before. So we have to be prepared for drought, and we have to be prepared for flood, even more so than in the past. We're seeing more in the way of extremes. Now, I sure hope we don't see an extreme like the mid-60s again, because there's a couple more million people living in New Jersey now than at that time. I dare say we are better prepared, but I don't know if we're well enough prepared to handle a drought of that magnitude. But we're kind of spoiled. As I said, it's really been since '02 that we've had a major drought. Sea level, we are a coastal state. No, we're not going underwater anytime soon. You might want beachfront property in Highland Park, but it's not going to happen that soon. But sea level is changing. Over the last century, about 12 to 18 inches of sea level rise along the Jersey coast. About a third of that associated with the land subsiding, so that makes the sea level higher. But about 2/3 because the oceans are warming and thermally expanding, and alpine glaciers and now some of the Greenland ice sheet and at least western part of Antarctica appears to be melting and adding to that sea level rise. So that's the trend we see. So you could say if Sandy came a century ago, areas that got a foot of flooding in their homes wouldn't have had any flooding. So it does make a difference, that 1 foot. So what about the future? As I said earlier, we have these models that can recreate the past, only can explain the thermal conditions for the last 50 years with human activities involved. So we run those into the future. The models, there's several dozen models around the world. These are run on some of the world's fastest computers, and they do differ. But the real difference in these model ranges you may read about or hear about isn't the models telling you something different. It's the fact that we don't know what we call emission scenarios will be in the future, or emission conditions will be. So we come up with a variety of scenarios. We stop burning fossil fuels, we just let things go on business as usual, and that leads to a wide range in predicted temperatures, maybe from a low of 3 or 4 degrees by the end of this century Fahrenheit up to perhaps 9 or 10 degrees Fahrenheit. And you may say, well, these guys don't know what they're talking about. And it's because we don't have a complete feeling on how we're going to handle these emissions of greenhouse gases. So you have to speak in a large range, but it's going to get warmer. In the Northeast, I'll show a map, it's going to get wetter, but not in all seasons. Hold on. Already talked a little bit about variability. Are we seeing those extremes already? Perhaps. But by the very fact that the word extremes connotes something that is unusual. So this is where I give my spiel about climatologists having to be quite patient. I say meteorologists get instant gratification or condemnation. At least I can escape that a little bit. But the fact is, all sorts more energy in the system and the atmosphere and in the oceans, more moisture in the atmosphere. So we could spawn major storms and floods. But even if we have the atmosphere loaded with moisture, if we don't have a trigger to get it down as precipitation, we still have a lot of heat, so we can dry out. Look what we just had, this flash drought in the last 6 to 8 weeks. So yes, we could have more of both, more extremes. And then sea level, it's going to keep rising. This is a national climate assessment of several years ago now. This is comparing the middle of this, projected the middle of this century's temperatures across the lower 48 to where they were at the end of the last century. Anything in red is projected to be warmer by the middle of this century than the end of this past century. I like to say anything in blue is going to be cooler. Not eye chart. And we're beginning to get models that can look seasonally, and this gets a little frightening. Summers warming more than other seasons, so hotter summers. So that's temperature. What do we want to look at next? Precipitation. And here, these areas should get wetter, these areas drier. This isn't telling you that it's dry here now in the desert Southwest. This is telling you the change expected mid-century compared to the end of last century. So the dry get drier and the moist get moister, and this area in the northern plains, particularly in winter, gets wetter. That wetness may be in the form of snow until temperatures can get above freezing, in which case it'll become rainstorms. So higher latitudes, we actually may see more snow as a result of warming with more moisture in the atmosphere until the temperature passes that magic 32-degree mark. And I'm not saying that's why there was 2 feet of snow in eastern South Dakota 2 weeks ago. North Dakota. But it kind of fits the picture. But I would never say that storm wouldn't have happened without climate change. You have to be very careful with that. Although there are studies now that are looking to very quickly determine the cause of major heat waves, major droughts around the world. There's these action groups that are trying to assess attribution. And they're finding, some droughts can only be explained with human influences. Some heat waves in particular only explained the magnitude of them with human interference. Major floods, it's a little trickier. Jury's out, you might say. But there are these action teams trying to look at attribution very quickly now. So again, winter's wetter, but look at the summers. drier perhaps and hotter. I don't care how warm it gets over the next century or two, we're not going to be growing corn in Iowa in January, where it's wetter and it's milder. Just not going to happen. So we're going to have to plan for these types of things. Sea level. This just gives you a little idea. We're actually updating numbers on projections of sea level. Just had a meeting yesterday. We put out a report at Rutgers in 2016, but DEP asked us to update it. It should be done in the next month or so. We met yesterday, we met a couple weeks before that. Come up with the latest numbers on sea level rise, expected 2030, 2050, 2100. We even probably got to put in, we discussed it, a 2150 estimate for the first time, kind of get into the next century. But these right now are pretty good ballpark numbers, and they're not going to change a lot in the new report. Likely a foot more sea level than this early century by 2040, 2050. 3 feet likely by the end of this century. An outside chance, 5% chance, which isn't exactly a tiny chance, but it's small, of 6 feet. And this shows you seaside heights. These areas will be permanently inundated, high tide, low tide, not just storms, with a foot rise. With 3 foot rise, these areas permanently inundated. And with a 6 foot rise, there goes your barrier islands and barrier peninsula. This is actually a peninsula here, seaside. This gives you an idea. This is done through njfloodmapper.org. It's colleagues at Rutgers have put together a wonderful way of depicting how sea level will change and the impacts of sea level rise. So that's the outlook. That's the outlook. It's not definitive. We can't put hard, firm numbers on it, but we certainly know the direction things are headed with all of these variables as we go through the decades ahead. So what's going to be the impacts? And here, I like to include this. Again, I defer to many wonderful colleagues at Rutgers, elsewhere in the state, universities, NGOs, and government who look at these things. The health impacts. You want to know about climate change? Talk to your local health officers. They tell me how the climate change is impacting what they're finding out there. Agriculture. I talk to the farmers. Forest impacts, water resources, of course our coastal areas, and then just generally natural wildlife, all influenced by rising temperatures, changing precipitation patterns, and coastal areas rising sea level. That's now underway and expected more so in the future. So what do we do? What do we do about this? This is my preachy slide. Some people disagree with some of the details of it, but I'll just put this out as a thought piece, if you will. Let's talk about knowledge. You're here tonight. Thanks for coming, because you'll hopefully leave understanding this a little bit more. Here's what I've really been preaching on the last couple of years. You haven't heard me say or ask one thing about, do you believe in climate change? Do you believe it's occurring? This has nothing to do with beliefs. This has to do with understanding. A belief is something in your heart or your head. It's just different than the understanding we all need to have. I filmed some for NJTV this morning with Steve Abadado for, I don't know when it's going to be on. I went up to Newark to the studios there. And he was asking me, what do we do about people that disagree with this, don't know what to do about it, don't think there's enough that we should do anything about it? I said, at least can't we all just get on the same page, understand what's happening, why it's happening, and then we can open some very fruitful discussions about what one might do about it. So, knowledge. Mitigation. There are things we do. I'm not going to leave you all down and depressed tonight, maybe a little. But there are things we can do about it. We can mitigate in some respects. I read something recently, just a week or so ago, that said, you know, we're kind of victims of our own success. We're very successful as humans in what we've done and what we've achieved, oftentimes by using fossil fuels. Well, you know, we achieved all these things, but now we're kind of facing the consequences of those achievements. But we were clever enough, smart enough, resourceful enough to have this success. There's hope that we'll be so smart enough, resourceful enough to figure a way out of this to a point. But we're not going to mitigate ourselves totally out of this. We're going to need to learn to adapt, or the buzzword now, become more resilient. I've been saying this for 30 years teaching. We're not going to mitigate ourselves totally out of this. It wasn't that popular that we might have to adapt, but now we understand we do. And I sit on committees for the Department of Transportation, for DEP, even the Office of Emergency Management with State Hazard Mitigation Planning. And it's mitigation planning, but they're still talking about adaptation. We're going to have to learn to adapt. We certainly learned that with Sandy, that you don't put pumps in basements that flood. You put them higher up. You don't put your transform stations. You might have noticed it in Hoboken. You don't put them in flood-prone areas. You protect them from storm surge and freshwater flooding. That kind of adaptive strategies. We can do that. We can do that. And finally, we need some activism, some leadership. Everything from the grassroots, local level with you folks and committees in this town and others. You know, go out and vote. Look at the platform of the candidates. Choose the issues that are most important to you, and then vote as you feel compelled to do so. I could tell you what's most important to you or how you should do it, but if you don't vote, you shouldn't say anything about it. That's the way I like to put it. So just by participating, you can be, some people say, well, what can I do on the local level? I'm just one person. Go and turn out the lights, turn down the thermostat. You know, I'm a trustee of the Nature Conservancy in the state. We were just meeting last week as a working group, trying to decide how we should pick and choose, because we can't do everything when it comes with climate change. We do a lot with living shorelines and such, but we were talking about transportation. We were talking about generation of electricity. We were talking about our homes, our buildings, and the need to cool and heat them. Those are three major uses of energy. So how can New Jersey kind of push beyond its weight in helping to promote this? And one thing we looked at, and be interested in what you think, but I'll just throw it out now, is transportation. You know, just look where we're situated and all the transportation hub we are. So there's where I think Jersey can push beyond its weight in helping to make or promote a difference. I know there's discussions of electronic vehicle legislation, shall we say, and other things. And this may be, none of those may be the most important to you. So pick something else and learn about it and talk about it out there. So enough preachy slide over. Sum up, climate change continues, it will continue and accelerate, and we can expect more extremes. Impacts are going to be felt and expand, but time remains for mitigative and adaptive actions to address and hopefully attenuate some of these conditions. And with that, thanks very much. See, even with the break, we're at the hour mark. I understand if you have to leave, but I'll answer questions.
Can you put the last slide back?
Can we put the last slide back? That's like a 1910 map of Highland Park I found. Whoops, wrong way.
So, the thing I find most concerning is that, you know, we told carbon dioxide is not recording, mercury means that water stays low. We're totally dependent on what India and China do. They have much higher populations, they're growing, they're building coal-powered power plants. And I think the U.S. could totally shut up the lights and we're not going to make much change.
Yeah, I mean, your question addresses, this is a global issue.
Can you repeat the question?
Yeah, the question is, you know, the U.S. can't do it all by itself. China and India are growing economies and producing more and more energy, still building coal plants. They're also advancing green energy better than the U.S. But before we get too complacent, and I don't want to give the old we should serve as an example, but the fact is it wasn't until the last decade or so that China began to produce more greenhouse gases than the U.S., yet they have, what, 5 or 6 times the population. So it doesn't let us off the hook. But you're absolutely right. The U.S. cannot solve this by themselves. This is a global issue. That's why we had the Intergovernmental Panel on Climate Change, which most nations are buying into, with one major exception right now. But thank you for mentioning that. This carbon dioxide, it spreads. We measure it at Mauna Loa and up in northern Alaska, and it mixes throughout the atmosphere. What happens here makes a difference elsewhere, but so also elsewhere has an impact here. So yeah, thanks for bringing that up. But it doesn't necessarily get us off the hook. And it also should promote cooperation, exchange of engineering and of innovative activities to circumvent some of these problems. Sir.
Hey, thank you. Recently there was a reporter who covered a zoning board meeting in New Brunswick who asked during the public comment what the zoning board officers were going to do about climate change. And the questions did not compute. They didn't know what to make of it. They said, well, this isn't part of the application. What are you talking about? Can we see any standards at some point in New Jersey where local zoning boards can factor in real climate, can factor in climate change in local decision making? Because you mentioned, taking it to the polls and how we vote. From the local level, there's never really a climate platform on the local level. I'd like to see one, but maybe, are there any standards on the way where we can really factor this out?
Yeah, real good question. I'm doing this partially because it's being taped here to kind of repeat it. What about coming up with standards for building, for engineering efforts that take climate change into account? I get questions about that. I just got asked by Delaware River Keeper or whatever coalition about return periods for heavy precipitation. And if you go off something that's 30 years old, maybe the 100-year flood or the 1% flood has changed now. We need to keep those standards updated. I just had a telecon with New Jersey Futures a week ago, and they're grilling me, there's 21 communities in the state that have mixed storm sewage with their regular sewage, and heavy rain events, their treatment plants can't handle it. And they have to come up with a plan for these communities. And all of a sudden they said, talk to Dave, because maybe we should have climate change considered as part of this. But a major step forward, they're considering climate change for part of this. Frankly, to be honest with you, I don't understand if it's legislation or plans that the communities have to put forth. I just can't follow all those things. But I think that's a positive sign that people are beginning to think when they plan about climate change. I sat on a Port Authority committee last year and learned a heck of a lot about all the Port Authority activities. Part of their interest was born of extreme storms like Sandy just whacked them. But while they were studying the impacts of these acute storms, they were looking at climate change as well. And I think that's one way of getting at it. Let's not just look at climate change, that's out there. Let's talk about severe storms and link them with climate change, this climate weather continuum. And then you might get people to recognize that, there's a lot we can do to prevent flooding from a return of a coastal storm that would have application down the road with climate change. So I think people are thinking about it more now, working on it further, but probably a ways to go. Probably quite a ways to go. Yes?
I wanted to ask if you're familiar with a book called Drawdown. You ever heard of that book?
No.
There's a copy of it in the Highland Park Library. It's a book that has 100 different ways to mitigate. And the reason it's called Drawdown is that they think the goal shouldn't be just stopping the increase in temperature, but actually bringing it back down.
Mm-hmm.
These 100 ways were all vetted by scientists and ranked in how effective they would be. They're all estimates, of course. You'd be surprised what the top. I think it's worth everyone here take a look at that book.
So the book we refer to is called Drawdown.
Drawdown.
Do you know the author?
Well,
It doesn't matter.
there's lots of different authors.
Okay.
There's an
Google
editor. It's a big format book.
Oh,
It's not something that'll fit on a usual shelf. But it's actually worth getting a copy. But if you wanted to just look at the one that's in the library, I think you'll find it well worth it.
It's also on
really
the internet.
encouraging.
It's a project that's on the internet. You can see almost everything that's in the book by going to the internet.
Okay.
Drawdown.
And you should take a
Interesting.
good look at it so that you can talk about mitigation.
in my spare time.
No, but really, for instance, one of the top 10 actually is education for girls and women in developing countries. You'd be surprised how much of a difference that can make. Electric cars, if I'm remembering right, may not be one of the top 10, for instance. So that you might find surprising.
Might not be, might not be. No, very interesting, and people are out there thinking, and there proves my point that the ingenuity of humans to try to not only just minimize the increases in these greenhouse gases, but to actually reduce them. It's very expensive. No one's come up with an effective way of pulling carbon dioxide out of the atmosphere.
Well, I beg to differ. So one of the obvious ones
Economically.
is more reforestation.
Yes.
And in fact, another interesting one, just to give you one more, is pasture land. Planting trees in sparsely on them actually helps, improves the grass growing, doesn't interfere with the amount of grass that grows. It actually improves it, but it also gets more carbon dioxide out of the air.
What country has planted the most trees? China.
There you go.
China. Yeah, I mean, there are a lot of things that one could be considering and one can do about this. It's not just a matter of letting things increase, but try to pull them down, and that's where the creativity of humans will hopefully prove successful. Yes, sir, you're impatient.
Can you talk about what I think is somewhat bizarre resistance to wind power offshore in New Jersey?
A little bit. I defer to my marine science colleagues and all. There's concern, the fisheries are concerned. Those just concerned with the health of right whales, for instance, out there. There's some that are afraid that it could damage bird migratory paths. Again, I'm just going to list these. I don't have strong, I'm not well read. I'm just familiar enough with these. And it's not just at the wind farms. For instance, the transmission cables that would have to come ashore with clammers and things like that. You have to remember, aquaculture in New Jersey is $1 billion a year industry. So they're concerned. Those are the kind of concerns. It's to the fish in the air, to the fish in, the birds in the air, to the fish in the sea. And I think there are others that just don't feel that it's going to be proven economically viable and will have to be perpetually subsidized. And that I really can't speak to. I hope that gives you a peripheral answer.
Why would it affect the birds in the sea versus the birds on land?
Well, it's just that these spinning wind the middle
Ones
school.
we have on land.
Right, and there's a lot of complaining about those.
Well, I mean, as far as the birds, it doesn't.
Well, that's where I can't speak. I've read that there aren't as many bird deaths as people might suppose
Right.
from windmills on land.
Right.
So there should be no
And they move
difference
very
in,
slowly.
should be no difference. These blades are gigundo
Yeah.
out at sea.
Yeah.
I mean, I'm familiar with some of the planning and all. They're going to build them upright, and they can't build, therefore they can't build them upstream of the Delaware Memorial Bridge because they can't get underneath the bridge.
Oh, yeah.
I mean, they're huge. So yeah, I don't know if that holds water, to tell you the truth.
I don't know that they're
That's what
defensive
people
to
said.
To whales either.
No, or human brain damage. You know,
We already have enough of that.
think about that. Yes.
Did I hear you say that the sandy pinelands have extreme temperatures and that it was the sand that it was due to?
Yeah.
Can you talk
Great.
about that?
Sure. The pinelands are some of our more extreme temperature regimes in the state because the soils dry out very quickly because they're very sandy. And when you have that dry soil, a lot of the heat's absorbed during the day and goes right into the atmosphere, and it doesn't go to evaporating the moisture in the soils. So they heat up a lot during the day, but at night it's very dry, and the atmosphere has less of a greenhouse effect, if you will, there. So the radiation can very quickly escape out to space. I mean, Saturday morning we had 18 of our 62 stations reporting below freezing, and 5 or 6 of them were in the Pinelands, from Vineland up to Berkeley Township, and others up in the northwest part of the state down to Hopewell. We were 34 on campus. So that's what makes it more extreme. That sandy soil heats up during the day, but it cools off more quickly at night.
Interesting.
A great fundamental dynamic climate question. Has nothing to do with change.
A question about the Gulf Stream. If it turns out that we have a mass melting of Greenland, could it affect the Gulf Stream's capacity to reach Europe?
Yeah, the whole idea about ocean circulation and its impact on at least regional climates, North Atlantic climate. This goes back to some theorization from the late 70s that kind of got made into the movie Day After Tomorrow. Actually, a professor who just passed away, Wally Broker, came up with this idea and tested it on my grad school class at Columbia. So I've been following this since I was in grad school, and I kept up with Wally. We maintained a friendship. And, you know, it's been tinkered with, but it started a whole generation of research in how this global circulation at the surface and at depth, this ribbons of circulation around the world, might be disrupted in the North Atlantic, which is a major, major point for forming deep water that sinks down the oceans and makes its way to the Antarctic and up into the Pacific, would change. And the idea there, if you melt a lot of fresh water, it's less dense than the salty water that comes up in the Gulf Stream, and there you wouldn't form the deep water. It would slow this sinking water, which means less would be pulled up the East Coast, and snows would fall in Great Britain, and ice sheets would invade New York City in a week's time. That's science fiction, but it's always kind of fun. That movie was pretty good if you sped it up by a factor of 10 or 20 or 50,000, although it didn't obey physics quite right, but we won't get into that. Right now, the prevailing thinking is that this would not occur. It might weaken it, which interestingly enough could affect sea level on the East Coast, because if that stream doesn't go as fast, more water could slosh up against the coast and sea level could rise faster in New Jersey without a strong Gulf Stream. So it's not considered out of the realm of possibility, but the general prevailing thought now is it wouldn't totally shut it off. But we do see fresh water coming off Greenland, and one of the only spots in the whole globe cooled in recent decades is the North Atlantic Ocean sea surface temperatures just south of Greenland and Iceland. And there's a little cool spot there, and we think that's associated in part with the added freshwater melt from Greenland. Yeah. Yes.
I have two questions. I watch the weather maps now, on the iPad, you get great weather maps. I noticed that a lot of our storms, and we've got a lot of rain coming here over this last summer, start in the Midwest. Now, I remember that they used to start in the Gulf and come up a ridge, like from Mississippi through North Carolina to us. Today, they're starting in the Midwest. How is that possible?
Yeah, I actually have a grad student, and she's looking at integrated vapor transport, looking at the moisture that makes it into the Northeast. And now next step is going to be, does it produce rain? And she finds one pathway with her self-organizing maps from the plains, and we haven't done time series yet, so I wish you asked that question 6 months from now. She needs to defend in 6 months. Ring me up in 6. But we're still getting our predominant moisture fluxes out of the Gulf and off the Atlantic. But there's one interesting part to this. Irrigation in the Midwest. I've been involved in a couple papers of some past grad students who looked at irrigation in Nebraska, Iowa, and we found a little enhancement of precipitation downstream from those areas because they're pulling water out of the Ogallala aquifer and putting it on land. That's evaporating and falling downstream. So there's a little bit of a signal. We never saw it making it to the East Coast, but there's some sign that that's one thing where we are slightly adjusting the atmospheric moisture profile, and that's through the irrigation of crops out in the Midwest. So, it's somewhat minor, but there could be a little signal. Yeah, we're still getting a lot of moisture out of the Gulf and off the warmer Atlantic Ocean.
Second question. I spent a vacation in Holland, the Netherlands. Have we learned anything from them? Flood control and canals and windmills and
yeah, and well, Netherlands.
Very well.
Netherlands have been at the forefront of trying to protect their lands from sea level rise after a huge storm in the North Sea in 1951, 52, somewhere around there. And they also lead with wind development. Ørsted, which had the first contract off New Jersey here, is a company out of the Netherlands. They're the biggest in the world for wind energy. So I believe there have been, 60 Minutes did a piece on that or something like that. This one developer over there coming over here and looking at levees and flood control and I guess the lower Mississippi, but there's been discussion about what to do here in New York Harbor. Do we put up some type of barriers? Again, it's going to be a cost issue. Will the costs be justified by what they may produce? We have that in Jersey. There was enough justification from the Corps of Engineers to put this flood protection around Bound Brook. They did an assessment for Manville, and they found it wasn't cost-worthy. So they used Blue Acre funds, and they're buying out a couple, I bet so far I think it's around, don't quote me, 100 homes in the Lost Valley section of Manville. So that's two different approaches, but one, they said, no, we're not going to invest in flood protection, but we will have these funds that we will buy people out and then turn those areas into parkland. So those are the kind of innovative approaches, but certainly we can learn a lot from the people in the Netherlands on that account.
Two more questions.
What's being done, if anything, downtown Manhattan, the battery park area?
Yeah. The question is what's happening downtown Manhattan. I don't know the particulars. I've seen some models out there, but I know, for instance, the Port Authority has portable flood control barriers that, given 2 days' notice, they put them around the World Trade Center complex. They need about 2, ideally 3 days' notice, and they can put a barrier around the World Trade Center and hopefully keep X level of storm surge flooding out of that complex.
Given all the construction
But that's only the Trade Center. That's not all Lower Manhattan. I think there are some plans for, I've seen them. I don't know how realistic they are, how expensive they might be, building dikes around Lower Manhattan to help protect them from surge flooding.
The Raritan River Valley.
The whole Raritan River Valley.
Pictures you have.
We've had, I didn't show, but Irene and Floyd are by leaps and bounds the two largest floods in the Raritan Valley since colonial settlement. About half again more water came down the Raritan in those two storms than anything we've measured in the last century. So after Floyd, you figured it was going to be a long time before we saw that again. And then 12 years later, along comes Irene. So, the Blackwell's Mills on the Millstone River over the Hillsborough-Franklin border has had 5 of the 7 largest floods in the last century since Floyd. 3 were nor'easters, Irene and Floyd. So we're seeing a lot more flooding, and I tend to believe it's not overdevelopment upstream. Those areas are not overly developed with impervious surfaces upstream. It's too darn much rain in the drainage basin in a short amount of time. And that, I think, is being triggered by a moister atmosphere, a warmer atmosphere, and we should probably expect to see more of that in the future. Now I'm going to leave you all depressed again. Yes?
It seems to me that we get more winds coming up from the Gulf in the summer and bringing that hot air up than we used to. Have those winds changed?
Yeah, well, that's an interesting question I get all the time. It's getting windier, or the wind direction's changing. And the darn problem is, I'm an empiricist, but before our network came in the last 15 years, where we've got anemometers at 60 plus stations, we had Atlantic City Airport, Newark Airport, and just a few stations. And they even have moved their stations over the years. So we don't have good long-term records to really get to the heart of it. But the fact is, we've had warmer summers, and that has been associated with a stronger Bermuda high off the East Coast, and that serves as a heat pump out of the south. We've had summers are just getting so much warmer, and it's not, we just had, what was it, the 5th warmest summer or whatever. That 95 degrees on October 2nd was the only record high broken this year in New Brunswick. Not like we're shattering the hottest of the hot. It's just the persistence of the warmth. Day after day, week after week, that is really grinding away in Jersey. It's not that we're blasting through record highs. Now, we're not getting many record lows and all, but it is a stronger propensity of winds coming out of the south from this Bermuda high. So you're on the right page there. Yes?
You're using words like mitigate, adapt, and these all imply that climate change is in our future, whatever we do. So my question is, okay, a couple of questions. Is there anything that can be, we can't do it, governments have to do, that can be done or should be done? Is it possible to not necessarily, well, it would be nice to reverse climate change, but to at least stop it at a point? Because, you can mitigate and adapt all you want, but eventually, if it keeps changing, it ain't going to work.
Yeah, in other words, is it going to run away eventually? Are we going to be able to keep it under wraps, keep it under control, or maybe even reverse it? And there, I'd like to get out a crystal ball and see what lies 50 and 100 years ahead. Again, I turn to the fact that there is human ingenuity. Things that we didn't think could get accomplished are getting accomplished. I just read something, what was it, earlier today or yesterday, about desalination. It's just too expensive. It takes too much energy. Well, now people are starting to come up with means, and I don't know what those means are, to maybe be able to do it more affordably. And people maybe never thought that could happen before. So there's always a hope for innovation. Reversing it, it's going to be awfully tough. You know, I could have thrown more numbers at you, but you have to realize with all this warming that's going on from increasing greenhouse gases, 93% of that warmth sits
In the ocean.
Thanks. It sits in the ocean. If we didn't have the oceans bringing in that heat, imagine what the atmosphere would be. But then again, we're heating the oceans, which is putting a hit on the coral bleaching, fish migration, just changing the ecosystems of the ocean. So if we were to clean up the atmosphere, we'd still have all that heat in the ocean. And you know, there's ways of getting it out of the ocean. It's called El Niños, a natural phenomenon. It's funny, I taught it yesterday in class, talked about El Niños. And what do I read this morning? There's a study out on Monday that suggests that El Niños are going to be stronger, shift more towards the Central Pacific because of the added warmth of the oceans from human activities. And we might have more super El Niños. You may have seen that as well. So, I mean, that's how quick things are changing. I teach something in class one day, and I missed reading it the previous day and here today, so tomorrow class will hear it. So things are changing, and there is hope that we can get innovative people out there, clever people, have the will as a society. You mentioned government. Yeah, we're not going to solve this individually with one person and another person. It's going to involve having to bring governments in here. Again, it's outside of my realm of expertise, but I'm confident enough to think that there are approaches that may help.
That's why you vote.
Future. That's
Well,
why you vote.
Yeah, like just stop using fossil fuels. I mean, renewables have come down in price. They're price competitive now. They're sometimes cheaper. The Midwest is going from coal to renewables for some of their utilities. I mean, you didn't mention that, but if we stop using fossil fuels, it would change. You know, look, carbon dioxide stays in the atmosphere for what, 100 years?
Longer than that. It's got long residence time.
Okay, so long residence.
Yeah.
But, you know, we should stop. We should be regulating methane that leaks from all of the fracking. There's a lot that can be done.
And that requires, these activities require government action.
Right,
which was your
but
point
you
that we
know
can't do
how
it.
many million people were in the street on September, what date was it? September 20th, I think?
Yeah.
You know, that's important. That young people don't want their futures foreclosed. And so, you know, we gotta support them because...
Steve asked me that today. He goes, Greta Thunberg was out there and all these people went into the streets. Do you think it makes a difference? And I've heard just something involved politically in protesting just yesterday, and someone said, it just makes the protesters feel better. But I don't agree with that completely. The young people are grabbing hold of this and trying to do something about change. They see their future. I can get all cute and all, the mayor's seeing her new grandchild. I have a 10-month-old grandson. And you know what? God willing, he's going to live to see the year 2100. Back when I started studying this in the 80s and 90s, 2100 was a long way away. No one was born who was going to live up to that point. Now there are people living on this earth that are going to be there in 2100. He's just trying to walk. He's not ready to go fight that yet. But it's his generation and generations that are in their teens and 20s that are going to be affected more than us. You know, the model suggests that no matter what we do right now, the climate's on its way to 2050, no matter what we do. But what we do now, the model suggests, will have a big impact on the second half of this century. Sid's got a picture there. So that's really tough. You know, I like to say politicians are on 2, 4, and 6-year cycles. And even human nature. Here's the other one. I don't know. I'm loaded with them. I talk too much. I'm a sports nut. And I like to say climate change is always in the top 20. But it generally doesn't break into the playoff picture. unless you get maybe a Katrina or Sandy, and for a little while it might, maybe not even for the right reason, but it brings attention to it. But then it sinks back there to 10, 15s or something like that. It's always there, but there's always something that supersedes it. That's a more acute, short-term action. And people need to get the idea that this requires acute attention now, because it's going to pay dividends in the future for our kids and our grandkids and beyond. But that's tough. That's tough human nature. So we have to find a way of, as I said earlier, we become successful. We should build on that success by knowing how to deal with these problems we've created along the way. And I think that's maybe our hope for the future. Yes.
An article in the New York Times today on climate change, it was arguing that the effects are actually going to be more severe than advertised. And the reasoning was there were things that aren't in the models because there isn't enough data to know how they affect the climate. Maybe things like, I don't know, maybe ocean acidification, for instance. Mm-hmm. You might know better than me which those are.
Well, yeah, I mean, the models are imperfect. The models are in middle age. You know, they started to be developed in the late 60s, right down the road at Geophysical Fluid Dynamics Lab, Suki Manabe, in Princeton. They're more sophisticated than I could have ever imagined when I was in grad school taking a course on climate modeling. But they're imperfect. We don't know, we don't have the spatial resolution, the temporal resolution, or all the bits and pieces that could go on it. We work with landscapes now in atmospheric chemistry. We still have to parameterize clouds because clouds are sub-resolution in many cases. I won't get into all the details. So and as such, there still may be surprises out there we don't know, that we haven't accounted for yet. Let's hope a couple of them are good surprises, because nothing says they can't be. But you're absolutely right, and I have to see the Times. I haven't had a chance today. But yeah, I mean, I said earlier, the IPCC is somewhat of a conservative document because it's by committee. So as such, you're going to hear some people talk in more of a doomsday manner than perhaps the general consensus holds. But you don't see any people saying it's going in the other direction. So it's been a ride, it's going to continue being a ride, but with folks like you who are interested and took the time out of your evenings to come here tonight, maybe that's some hope for the future as well. Hopefully the younger ones, they're home studying, and they'll be part of the future to solving this problem or addressing it in a real powerful and meaningful manner. And I think that's it.